Hello, everyone. Welcome to an exciting series in math. This time it's calc. Specifically, it's techniques in derivatives. So in this series, we're going to introduce derivatives, then apply special techniques or certain techniques like the chain rule, product rule, quotient rule, then do implicit differentiation, logarithmic differentiation, and then apply these techniques to tangent problems, to related rates problems, and to optimization problems. But the first video, which is this video, is going to introduce derivatives, and then we're going to solve some problems, which will lead to the new techniques or the different techniques we will learn later. So let's get started. All right, so these are the standard derivatives that we'll be working with. We're not going to do inverse functions, inverse trig functions, and hyperbolic functions. We'll save that for another video. So again, we need to be familiar with these. Also familiar with the, if we're taking the derivative of the sum and difference of two functions, then it's the individual derivatives added or subtracted. Okay, it's the sum and difference of individual derivatives. If a constant times a function, we're taking its derivative. And here we're using prime as a derivative. It's much easier than writing ddx. It's less cumbersome. It's basically here the derivative of these two, the constant sticks around, times the derivative of the function. And also, if we're taking some k, which is constant, or let's in this case keep it consistent, c, its derivative is 0. Okay? All right. So let's go ahead and begin working out problems. First problem. So again, we look at these. Just take a second to look at them. We see here that this x squared is in the denominator, so we rewrite as a power, because remember, we're going to use the power rule, which is the first. This is the power rule right here. Okay, we have some x to a power times a constant. It's the constant times the power times x to 1 less power. Okay, and then the rest will follow. So again, familiarize yourself with this so we can go through the problems. So now we take derivatives. It's basically the derivative of the first term plus the derivative of the second term plus derivative of the third term. Derivative of first term, we have a constant. Again, it comes along for the ride. We drop the power rule here, x to 1 less power, plus. Yes, we look at this and we see a sign. We say, yeah, okay, derivative of a sign. But let's think about it a little bit more. This is not the sign of x. This is the sign of a number, which is a constant. A constant times 2 is still a constant. Its derivative is 0. Okay? Plus 3 halves e to the x. The constant comes along. E to the x, its derivative is itself. So here we get negative 6, x to negative 3, plus 3 halves e to the x. Now you can bring the negative x to the negative 3 down. And this is the answer. Right? We have this polynomial over x cubed, find y prime. Again, all we have is the power rule. And then sine, trig functions basically, and exponential functions. Log functions. This is not in our book of rules. However, we can use our algebra to simplify this to make it so that we can use one of these rules. So all these terms are divided by x cubed, and we can break it up. Just like this. Now we simplify here a little bit. Okay. Actually, we could just make it on one shot. Bring the x cubed up, becomes x to the negative 3, and I have a 1, so that's 3x to the negative 2. Bring the x cubed up, it becomes x to the negative 3, and there's a 2 on top, so 2 minus 3 is negative 1. And here we have x, we have a half on top, we bring in the negative 3 up there, so let's do it on the side. 1/2 minus 3. Okay, that's 1 minus 2 times 3, 6 over 2. That's negative 5/2. Okay, so that's negative 5/2. So now we can take derivatives because now we put it in power rule format. So go ahead and now take derivative of each term. The 3 comes along for the ride. We drop the power, the variable to 1 less power. Minus 2 comes along for the ride. We drop the power, x to 1 less power. And then here, same thing here. We drop the power, x to 1 less power. So we can simplify a little bit. Here we have negative 6, x to the negative 3. You have plus 2, x to the negative 2, minus 5/2, x to the negative 7/2. And there is our answer. We can simplify by factoring out x to a certain power, but that's good. Okay, that is acceptable. All right. Here we have tangent, secant, and e to the x. Now the tangent is divided by 2. Okay, so this is, again, let's write it in a form that we are familiar with so that once we practice these, next time we see this, we really don't have to go through this step. But let's first go ahead and see the steps. So tangent x over 2 is the same as 1/2 tangent x. So now we can see that we put it in a form where we have a constant times a number. Minus secant x. Same thing with e to the x. So I put a fourth here. Here you go. Now I can take derivatives. It's the derivative of the first term minus the derivative of the second term minus the derivative of the third term. The 1/2 times the function, again, when I'm taking the derivative of those, the 1/2 comes along. For the right now, I take the derivative of the tangent, and that's the secant squared of x, minus derivative of secant is secant x tangent x, minus the 1/4 comes along for the ride. Derivative of e to the x is itself. And there it is. There is the answer. All right. So let's look at this. And let me change this here. There you go. All right. So again, think about the problem for a second. And See if you can simplify it, if you can make it match some of the stuff that we already have on the first page. Now this one we can work with. We can easily bring this up there and becomes a power rule. That is good. But here we don't know how to do this. We don't have a formula to do some function of x to a power. But we can simplify this. So we can write x squared minus 5 quantity squared. We can expand it out using the binomial theorem. So now we could square the first. X squared squared is x to the 4. Then the first times the second times 2. So that's negative 2 times 5 is 10, 10x squared. Then square the negative 25, the 5, and you get 25. So now we simplified this into this. Now we look at the natural log. Again, the formula was the natural log of x prime is 1 over x. But that was the natural log of x only. Here I have things together. X times something else. However, we know that if we have the natural log of two things multiplied, it's the sum of their individual logs. So we can simplify ln of x times e to the x as ln of x plus ln of e to the x. Again, we look at this and we say, okay, my formula says you can only take the natural log of x, take the derivative of that. This is not the natural log of x, that's the natural log of e to the x. But we need to remember that the natural log and e are inverse of each other, so that the natural log formula or the of r is r. Okay? For any r. In this case, we have the natural log of e to the x. This is just x. So now we simplified this, which is right here. And then we simplified this, which is a combination of these two. So now we can rewrite this in a form that we can work with. So y equals, bring this up, 3/2 x to the negative 2/3. Here we have a half times that fraction. So here's the half right here. I expanded this to x to the 4 minus 10x squared plus 25. Then the last one is plus, again, this gives me this, but this here gives me x according to these. So ln of x plus x. And now I can take derivatives. Okay? So I have a lot of terms here. They're added and subtracted. So the derivative is the derivative of each term. The derivative of the whole thing is the sum and difference of the individual derivatives. So y prime, here we have the 3/2. We drop the power from x to 1 less power, and that's it. Plus 1/2 comes along for the ride. Excuse me, derivative of x to the 4. Again, drop the power, x to 1 less power. Minus the 10, it's times some function of x. So it comes along for the ride. Now I'm taking the derivative of x squared. I drop the power, x to 1 less power. Plus 25 is a constant by itself. Its derivative is 0. Plus, now I'm at the ln. The derivative of the ln of x is 1 over x. Plus, the derivative of x is 1. So simplify a little bit. 3/2 times negative 2/3 is negative 1, which I'm going to just put a negative for. And then now here I have x to the negative 5/3. I'm sorry. plus 1/2. Here I have 4x cubed minus 20x plus 1 over x plus 1. Okay? We can let the half multiply each of these terms and then bring this down maybe. So we'll have negative 1 over x to the 5/3. When I let the half in, it's 4 over 2, gives me a 2x cubed. This times that will give me a negative 10x plus 1 over x plus 1. There is the answer to this problem. Well, let's look at this. Here we have 3 terms multiplied. Again, all we know is the power rule, which says cx to the n prime is cn x to the n minus 1. And then I have trig and log and exponential functions. But if I expand everything out here, I can put it in individual terms like this, and then I can take their derivatives. So let's go ahead and expand this. To do so, let's multiply these two first, and then the product gets multiplied by that. So let's work with these. X times x, x squared. Here's 3x. Negative 5x, negative 15. That's the first two factors multiplied. Then I have the other factor sitting here. Simplify the first factor here. So we have x squared. 3x minus 5x is negative 2x minus 15. And now I have 2 minus x over here. Excuse me. Again, now I expand. This times the 2, so give me 2x squared. Negative x cubed. Now this times that, give me negative 4x. Negative 2x times negative x is plus 2x squared. Now negative 15 times 2 is minus 30. And negative 15 times negative x is negative 15x. Can I combine some terms? Of course I can. Let's write them in decreasing power. So this is negative x cubed. Here I have a 2x squared and 2x squared. That gives me 4x squared. Negative 4x minus 15x is minus 19x. And the only thing that remains is the negative 30. Now I take derivative. So it's basically the derivative of this. Let's just maybe write it explicitly. Eventually, we will not write the explicit form like this unless we're dealing with a complicated problem, which we'll see in the next few videos. So now what's the derivative of negative x cubed? The negative comes along for the ride, and now x cubed will drop a power, x to 1 less power. So 3 minus 1 is 2. The second term, 4 comes along for the ride. Derivative of x squared, we drop the 2, x to 1 less power. You have negative 19x. So derivative of that is just negative 19. Derivative of 30 is 0. Now, what we could have done is we could have taken this as 1 unit and did this derivative with 1 shot. And here's how we do these. Whenever we see a linear equation like this, in other words, we see an equation y equals mx plus b. And in our case, it will be negative 19x minus 30. This represents a straight line. And what is the derivative? What's the geometric interpretation of the derivative of a graph? It's basically the slope of the tangent line to that graph. And since we have a straight line, the tangent line is the straight line itself. So y prime here will just be negative 19, the slope of the line right there. So we could have taken these two as one unit and said, oh, that's a straight line. Its derivative is just the slope. And we can see that here. Negative 19 minus 0 is just negative 19. So simplify here. Negative 3x squared plus 8x minus 19. All right. Keep pressing more. Okay, so let's do this one now. All right. So again, let's give it a little thought. This one looks different because we are given the log of some base a of x. Its derivative is 1 over the natural log of a times x. That's not what we have over here. We have here log x to a power, and the log doesn't have a base. But we have to remember that log base e is written as natural log ln, and log base 10 is written as log without a base. So it's not explicitly saying 10, but we should remember this from algebra. And then I have this here, e to the natural log of x squared. I know how to do this. That's one of the formulas. The derivative of e to the x is itself. But now I have e to a function of x. But let's look closely at that function. Again, just like there was a rule, ln of e to something equals that something because ln and e are inverse. The same thing here, e to the ln of something equals that something. Okay? So in this case, for our problem, the ln e to the ln of x squared is nothing but x squared. Okay? Here's that box right there. So that one is resolved to x squared. But how about this? Again, tapping back into our algebra, we should know that the log or the ln, doesn't matter, like log x to a power is the same as, we bring the power to the front, log x. I'm not taking derivatives, that's just property of the natural log or the log, okay? So in this case, the 2/3 can come in the front. And now I will have a form like this, which I can take the derivative of. So now that we looked at it, analyze it a little bit, put it in a form that we can work with, let's go ahead and write it out. Y equals, again, this comes down 2/3 log x plus 2 to the x minus, again, we said e to the ln of x squared is just x squared. Now I have it in a form that again, here, there's a hidden 10. It's there. Now I can take derivatives. So y prime equals derivative of this term. 2/3 comes along for the ride. Now I have log base 10 of x. Log base a of x. This is 1 over the ln of 10 times x plus 2 to the x. The derivative of this is, again, the ln of 2. Again, it's one of the formulas that we have, times 2 to the x. Minus derivative of x squared is just 2x to the first power. So can we simplify things? Oh, this is it, basically. So again, we got to look at the problem and try to simplify it, put it in a form that we can work with, and then there's take derivatives. All right. Here we have Everything was looking good. I mean, we have a constant, we have a sine, we have a cosecant, except now I have a natural log of 1 over x. Again, my rule says the natural log of x, its derivative is 1 over x. But here I have 1 over x. Again, typing back into algebra and pre-calc, the ln of m over n, two things divided, is the difference of the individual logs. Also, we need to remember that the ln of, or any log of 1 is 0. So now, the ln of 1 over x, let's put these two together. This is the ln of 1 minus the ln of x. Again, is the ln of the top minus the ln of the bottom. And I see I have an ln of 1, so that's 0 minus ln of x, which is negative ln of x. Another way this could have been done, 1 over x is basically x to the negative 1. So ln of 1 over x equals ln of x to the negative 1. And what did we just talk about a second ago, right here? The log of x to a power, we bring the power in the front. Basically, we take the power from the x and put it in the front. Same thing here, we can bring this negative 1 in the front. So that's negative ln of x. Obviously, these two have to equal each other, and there they are. So now we simplified the problem into something we can work with. Let's rewrite it. 3 minus 4 sine x minus ln of x minus 2 cosecant x. Now take derivative. The derivative of 3 is 0 because it's a constant. Minus 4 times the function of x, so the 4 comes along for the ride. And now I take the derivative of the sine, which is the cosine of x. Minus, I'm at the ln right now, the derivative of the natural log is just 1 over x. Minus 2, the derivative of the cosecant of x is negative cosecant x cotangent x. So you have negative 4 cosine x minus 1 over x plus 2 cosecant x cotangent x. There's the answer. All right. Nothing looks like it needs to be simplified here. We know how to take the log of a base of x, exponential function, cotangent. We can just go ahead and take the derivative of each individually. So y prime, 1/2 comes along for the ride, log base 3 of x. This is 1 over ln of 3 times x minus 4 to the x is ln of 4 times itself plus cotangent of x, that's minus cosecant squared x. So the plus and the minus here, I'm going to combine them into a minus, and there is the answer, right? So this is it for this video, but in the next videos, as you can see here, and let's go back to the beginning. All of these have x in them, here and there. These are, in a way, special cases, because what if we have e to the x squared minus 5, or ln of x plus sine x? These are functions that are legitimate, and you need to be able to take derivatives of these. So what we're going to do next time is we're going to expand this. We're going to use the same rules right here, But now work with, instead of having x's here, we're going to have functions of x. So we'll have the sine of some function of x, not just x. It could be x, it could be function of x. And when we work with these, this is called the chain rule. Just like we have these rules, the chain rule builds on these rules and adds something to them so we can solve more complicated problems. So that's the topic of the next video. Thank you for watching, and I hope to see you soon in the next video.